Okay, so May, June 2023, 2. Okay, and I'll try to, we will do the February, March 24 as well. And you guys have a exam paper too? 13th of May. Yeah, so we have a time, so we can do. Okay. Now, question number 1. The melting point of some solids are shown in table 1.1. Okay, magnesium. As we know, it's a metal, right? Phosphorus, non-metal. Sodium chloride, ionic, and sulfur, non-metal. Yeah, and it's a ionic bonding. These two have a covalent bonding, and this one have a metallic bonding. Okay. State the type of bonding present in magnesium and in sodium chloride. So in magnesium, it's a metallic bonding, and in sodium chloride, it's ionic bonding. Okay. Now explain the difference in melting point of magnesium and sodium chloride. Okay. If you see, sodium chloride has a melting point of 1074 degrees Celsius Kelvin, and it has a 923 Kelvin. So it difference is not that much bigger, but still sodium chloride has a higher melting point. So it means bonds in sodium chloride are stronger than magnesium. So bonds in sodium chloride are stronger than magnesium, and that's why sodium chloride has a higher melting point. Part 3. Explain the difference in melting point of phosphorus and sulfur in terms of structure and bonding. Okay, so if you recall, yes. Yeah. Yeah, octaatomic. More electrons, and phosphorus is tetraatomic. So very good. Then P4. Yeah, good. Yes. If it's related to this, then ask right now, otherwise after the class. Both P4 and S8 are simple molecules with van der Waals forces of attraction. So see, as I've written P4 and S8, so I don't need to explain that phosphorus is tetraatomic and sulfur is octaatomic. Weak van der Waals forces of attraction. Yes, very good, Fiza. Okay. Attraction between the molecules. S8 has more electrons, hence stronger van der Waals forces or stronger instantaneous dipole forces. Okay. Now define electronegativity. Again, David. Very good. To pull or attract the electrons. The ability, or you can say the power of an atom. The ability of an atom to pull electrons towards itself. Yeah, because electron affinity is the force by which an atom gains an electron. and electron negativity is the force by which it is attracting which are already part of that atom or ion, and it is attracting those electrons towards itself. That is electronegativity. But when we say the electron affinity, so that is the force by which it gains the electron in it. Okay. Now explain why electronegativity increases across the period. 2 marks, so you need to put two reasons. The nuclear charge increases.
So what is the question?
Shielding, yes. Shielding if stays the same. And then, okay. Yeah, the nuclear charge increases means number of proton increases. Yes. What else? The most important thing you guys missed. The question is, Umar, why electronegativity increases across the period? Yes, Fiza, you are correct, but still you missed one thing. Yes. As a result, the nuclear attraction increases. If you don't put this thing, then you will not get the second mark. Okay. So across the period, nuclear charge increases and shielding remains same. Hence, nuclear attraction gets stronger. So if they get stronger, it means that the electronegativity increase. So the reason, if you see, it's same as for ionization energy. In both the ionization energy and electron affinity, we have a same reasons. Okay. Now, name the strongest intermolecular force that exists between ammonia molecules. Hydrogen bonding. Okay. If I ask you, name the strongest force of attraction between propanol molecule, non. If I ask you the strongest attraction between propanol molecules, yeah, permanent dipole forces, because if you see, propanol has a dipole in it, right? And due to this dipole, the strongest force between the molecules is permanent dipole. Now, if I ask you the strongest intermolecular force between propanol and water, hydrogen bonding, because the oxygen of propanol can form a hydrogen bond with the hydrogen of water, but between propanons there would be no hydrogen bonding. And due to the same reason that there is a hydrogen bonding which exists between propanol and water, and that's why it gets dissolved in water. So the covalent compounds are dissolved in water by due to two reasons. One is they can form hydrogen bond with the water. That's why they dissolve. What is the other reason? Covalent substances dissolves in water by two reasons. One is they so they form a hydrogen bond, right? So that's why they give me the other reason. Ionic compounds ionizes. They hydrolyzed. So that is the key word when examiner, sometimes examiner explain you that the compound hydrolyzed in water or reacts with water. So it means that, and then they ask you what suggests the bonding. So if they ask you that it is hydrolyzed or reacts with water, so it means it has a covalent bonding. But if they say it is just ionized in water, dissociates into ions, so it is ionic bonding. Okay. Now, draw a diagram to show the formation of the strongest intermolecular force between two ammonia molecules. Okay. Include any relevant lone pair of electrons and dipoles. So see, if you don't miss them, you will not get the second mark. So you can do it like this. Put one ammonia. Nitrogen is partially negative and hydrogen is partially positive. Then make another ammonia molecule like this. Nitrogen is partial negative, hydrogen is partial positive. Nitrogen has a one lone pair of electron, and from that lone pair of electron, you just make a dotted line towards the hydrogen of the other molecule, which shows hydrogen bonding. So if you draw the structure correctly, but if you miss these things, then you will not get the second one. Okay. Now, part 5. The melting point of ice and ammonia are shown in table 1.2. Okay. Ice melts at 273 Kelvin and ammonia melts at 195 Kelvin. Suggest two reasons for the difference in melting point of ice and ammonia.
They both have hydrogen.
So that is the common thing. So that's not the difference.
That's is oxygen more electronegative than
Very good. How oxygen is more electronegative than nitrogen. So it means the hydrogen bond would be going to be stronger in between the water. What would be the other reason? Yes, very good, Ishan. There are two hydrogen atoms in a water molecule, and there are three hydrogen atoms in the ammonia molecule. But one water molecule forms two hydrogen bonds, and one ammonia molecule forms only one hydrogen bond. Oxygen is more electronegative than nitrogen, and one molecule of water forms two hydrogen bond and one molecule of ammonia forms one hydrogen bond. Is this clear to all of you? Okay. Now we are going to start question number 2. Chlorine is a reactive element. It forms many compounds. Okay. Complete table 2.1 show the maximum oxidation number of elements sodium to phosphorus in their chlorides. Okay. If you look at the periodic table, see that chlorine is present in the same period. So it means what is the electronegativity of chlorine with respect to other elements of this period? It's the highest. So it means whenever chlorine bonds with the other elements of its period, chlorine is going to be negative, has a negative oxidation number, and the rest of the elements are going to have a positive oxidation number. Is this understandable? Okay. So we have to put the oxidation numbers over here. So sodium is in group 1, it's in group 2, it's in group 13, it's in group 14, and it's in group 15. So it has a +1, +2, +3, +4, and +5. Because if you recall, it's from PCl5, it formed SiCl4, AlCl3, MgCl2, and NaCl, and chlorine has a -1 charge. It's simple. Sodium has a 1 electron. So sodium loses its 1 electron to chlorine, making it +1. Okay. As the number of electrons in the valence shell increases, so they have a same oxidation number as the number of electrons present in their valence shell. When they are bonded to chlorine, why? Because chlorine is more electronegative than these. That's why. And how we figure out that chlorine is more electronegative? Because chlorine is over here in the same period. So if as we have just discussed that across the period electronegativity increases, so it is going to be the most electronegative one. Okay. So it will become it has a negative oxidation number and the rest of the elements has the positive oxidation. Okay. State what determines the maximum oxidation number of elements in the period 3. Yeah, the number of valence electrons. The number of valence electrons. Now B, an excess of cold water is added to chloride of silicon. It means with SiCl4. Okay. Write an equation for the reaction between excess of cold water and SiCl4. H2O. It gives you SiO2. Okay. If they ask you here, they ask you suggest the pH of the solution produced. Yeah, it can be 1, 2, 3 because SiO2 is also acidic and HCl is also acidic. So let's write 2. Okay. What are the state symbols for SiO2 and HCl?
Solid, aqueous.
SiO2 is a solid because it's water insoluble, a giant covalent structure, and HCl is the aqueous. And also, the examiner asks you to show what will observe and white precipitates. If for 2 marks, white precipitates because SiO2 formed. Yeah, because it's a iodide, it's not iodine. When it turns into a iodide, bromide, fluoride, they are colorless unless they are bonded with the transition metal. An excess of cold water. Okay, just wait for a azan. Okay. Now, an excess of cold water is added to a chloride of phosphorus. Write an equation for the reaction between an excess of cold water and a chloride of phosphorus. So which chloride we are going to use? We are going to use PCl5 plus H2O. And in this case, the product is PO4 and HCl. And if we balance the equation, 3, 2, no, 1 minute, 5, no, it's not 6. Into the 16. Two. Now it's 9. So 18. Yeah, you can simplify it. So if I simplify, yeah,
So what are the questions?
you have to balance it. We'll do this. This is the simplified form. So both can be considered as correct. Okay. Such as the pH. So as phosphoric acid is formed and hydrochloric acid, both are a strong acid. So 1 or 2, you can write any pH. Okay. Write an equation for the reaction of chlorine with water. Yeah. Yes. Yeah, it's a disproportionation reaction in which chlorine is oxidized over here in a HOCl or HClO, both way it can be written, and then HCl where it is reduced. Okay, write an equation for the reaction of chlorine with hot sodium hydroxide. So if you recall this reaction here, this is also a disproportionation reaction where chlorine forms one NaCl, one NaClO3 and water. Okay, to balance the equation, you have to put 3 and 5 over here, 6 over here, and 3 over here. That is how you balance the equation. Yes, Omar.
And redox is proportionation.
Sorry.
Redox is
And okay, redox is the one in which one substance undergo reduction and the other substance with which it is reacting is an oxidation. It's a redox. Okay. Disproportionation is also a redox, but see, its oxidation number is 0. And how many chlorine here we have 2? So the same element, one of the atom is reduced, and the other one is oxidized. If a same species oxidized as well as reduced, then it's a disproportionation.
इसमें atoms का होता है.
Yeah, see, it is reacting with another substance, right? Sodium hydroxide. In a redox, if it is undergoing reduction, then it would undergo oxidation. That is a redox. But if the same thing is undergoing both oxidation and reduction, then it's a disproportionation reaction. Okay?
No.
Good. Now, E part. Bleach is used as a cleaning product to kill bacteria. It is made by adding compounds like sodium chlorate, 1 NaClO to water. Identify the formula of the ions in the bleach that kills bacteria. Yes, which ion kills bacteria? ClO minus the chlorate 1 ion actually. Yes, very good, Fiza. Sodium chlorate 1 reacts with the hydrogen peroxide to produce sodium chloride, water, and oxygen. Construct an equation. So see, in this they have given you all the things, water reactants and water products. So the reactant is NaClO, which is reacting with hydrogen peroxide. You must remember the formula, it's H2O2 to produce sodium chloride, NaCl, water, and oxygen. Now what you have to do, you have to balance it. And I think, yeah, it's already balanced. There is no need of balancing. 3 oxygen both sides, 2 hydrogen both sides, 1 chlorine both sides, and 1 sodium both sides. Okay. Now mole part. Okay. A sample of bleach W contains an unknown concentration of sodium chlorate 1. Okay. 10 centimeter cube of W is diluted with distilled water to make a total volume of 100 centimeter cube of bleach solution. 25 centimeter cube of this diluted bleach solution is added to an excess of hydrogen peroxide, and the volume of gas produced measured under room conditions. The experiment is repeated, and on average 25 centimeter cube of diluted bleach solution produces 42 centimeter cube of a gas. Okay, calculate the concentration in gram per dm cube. Okay, sometimes the student lost the whole thing, so if you make a little summary from this, then it will be very easy for you. So see what they are saying initially, that you have a W, you took out its 10 centimeter cube. And then that 10 centimeter cube is mixed with distilled water. And as a result, 100 centimeter cube of solution is prepared. And from that 100 centimeter cube of solution, 25 centimeter cube, this W is what? Bleach. So that is taken out. Okay. This bleach is taken out, 25 centimeter cube from that 100, and it is mixed with, okay, is added to an excess of hydrogen peroxide. So we don't know the volume of hydrogen peroxide, right? The experiment is repeated and on average 25 centimeter cube of diluted bleach, it means this amount of diluted bleach, it was diluted, right? Produces 42 centimeter cube of gas. So if you see, we have only one gas over here. So what they are telling you that it is formed over here is 42 centimeter cube. So if we know the volume of a gas, we can easily convert it into moles. Very good. So moles of oxygen would be, and it's a 42 centimeter cube. So volume of a gas divided by 24 decimeter cube or 24,000 centimeter cube. The volume is in centimeter cube. So we'll divide it with 24,000. So we'll get the moles of oxygen. Yes, what is the moles of oxygen? 1.75 exponent minus 3. These are the moles of oxygen. Is this clear to all of you? And what we have to do, we have to calculate the concentration in gram per dm cube of in W, right? Okay, so now take the mole ratio because we have to know the moles of sodium chloride, NaClO. So their mole ratio in the balance equation is 1:1. So if the 1 mole of oxygen is formed, it must be formed from 1 mole of NaClO. If we have a 1 mole, if 1.75 exponent minus 3 moles of oxygen are produced, then it must be formed from X moles, and that X is going to be the same, right? Because the ratio is 1:1. So 1.75 exponent minus 3 moles of NaClO are formed. Till here, is this clear? This is the point where most of the student did mistake. In which solution we have found these moles?
Volume.
In which volume? Yeah. The 25 of diluted. If you didn't do this and if you are not understanding the comprehension, then what students do? Take this mole and with this volume and then they calculate the mass. So obviously you are going to get the wrong result. So this moles are actually calculated in 25 centimeter cube of diluted solution. So 20, and that solution we took out from the 100 centimeter cube. So 25 centimeter cube contains this much moles, 1.75 exponent minus 3 moles. Yes, from where, Banin? So the 100 centimeter cube has X moles. No, not W. Yeah, W is in 100 centimeters.
I'm not sure which one that you said most people can mistake at this point.
See this thing. See this thing. Let me repeat. There is a bleach which is labeled W. What they did, they take out 10 centimeter cube from this bleach and then mix it with the distilled water, and as a result, 100 centimeter cube of volume is made. And from that 100 centimeter cube, they take out 25 centimeter cube. Yeah, now the 100 centimeter cube is diluted and we take out this 25 centimeter cube of the bleach and we mix it with the hydrogen peroxide. On this reaction, we got 42 centimeter cube of a gas, and gas is this. They just made us to write the equation in the previous part. So there is only one gas. So it means they are referring to the volume of the oxygen only, which is 42 centimeter cube. So, yes, Banin, did you understand this thing? Okay, now if we know the volume of the gas, then we can easily convert the volume of a gas into the moles, right? It's in centimeter cube. That's why we divided it with 24,000 centimeter cube. So we got the moles. Now, from the equation, we took the mole ratio. It is 1:1. So it means the moles that are formed from are of oxygen, that the same moles are for NaClO in its 25 centimeter cube, because 25 centimeter cube is reacted with H2O. Is this clear?
Yes.
Okay. Yes, Banin, did you understand? Omar, clear? Okay. Now we take the ratio that 25 centimeter cube contains this much volume, this much moles. Then how much moles present in the 100 centimeter cube? So the X is 7.0. Okay, 7.0 exponent minus 2 moles. So these are in minus 3. Okay, these are in 100 centimeter cube. Okay, now think that 100 centimeter cube in which we put just 10 centimeter cube of a W, right? In 100 centimeter cube of a volume, what we did, we just put 10 centimeter cube of a W. So it means if I say that instead or in 10 centimeter cube of W, the moles would be the same. Is this clear or not? No, it's not clear. Okay.
Are most 75
No. But see, the 100 centimeter cube has how much W?
lengths?
And 90 centimeter cube is?
What like?
So whatever the moles present of NaClO is present in 100 centimeter cube, all of them came from 10 centimeter cube of W. So it means the moles that you have calculated for a 100 centimeter cube solution are the moles which are actually present in 10 centimeter cube of W. Is this clear? Now we got the moles. They are asking you to calculate the concentration, and the unit they have given you grams per decimeter cube. Okay, so what you will do, you will convert these moles into grams. So mass is equals to moles times MR. So what would be the MR of NaClO? Na is 23 or 23.1. You missed oxygen. No, or you added 35.5 and 16. So what is the MR?
It's 74.6.
74.6. Now if you multiplied them, you will get the moles. Oh, sorry, grams. Zero 0.522 grams. Now these grams in how much volume? 10 centimeter cube. And we have to find the gram per dm cube. So 0.522 divided by 10 divided by 1000. Because we have to, the 10 centimeter cube is the volume, so we have to convert it into a decimeter cube. That's what we do for a concentration. Yes, what is the answer? $52.2, I suppose.
Yeah.
52, yeah, 52.2 grams.
How many marks?
Sorry,
How many marks?
3 marks. So 52.2 grams. Is this clear to all of you? Okay, we are done with question number 2. Now, question number 3. Figure 3.1 describes a sequence of reaction that can be used to produce a food additive compound Y from chloroethane. Okay. So if you see X is a nitrile and it's a chloroethane, so it means the reagent is potassium cyanide or sodium cyanide and ethanol, and it's a nucleophilic substitution reaction where chlorine is substituted by a nitrile. Then see, dilute acid is added and carboxylic acid formed. The type of reaction is hydrolysis, because on hydrolysing nitrile we get the acid. Okay, now in step 3, there calcium is added, and as a result we got Y. So Y must be CH3, CH2, COO, twice Ca, because calcium is in has a +2 charge, and it's a acid metal reaction because metal is added to acid. Okay, now state the reagent and conditions for step 1. So step 1, the reagent is KCN, condition is ethanolic and heat. Give the systematic name of X. Yes, who is going to tell me the systematic name of X? Propane nitrile, very good. No, it's not ethyl nitrile. See, there are 3 carbons beneath, not 2. Propane nitrile. Then identify the type of reaction that occurs when dilute acid is added to X in step 2. So we have already decided that it's a hydrolysis, and if you have to specify it, it is acidic hydrolysis. Because acid is being added, and due to this, nitrile converts into carboxylic acid. Okay. In step 3, why and gas is produced. Okay, so construct an equation for step 3. So the gas would be, when acid and metal reacts, hydrogen is the gas. So it's a propanoic acid. So CH3, CH2, COOH reacts with calcium. We know acid and metal reacts to form salt and hydrogen gas. So H2 gas has been formed, and the formula of the salt would be, as hydrogen is released, so the propanoid ion has a -1 charge and calcium has a +2 charge. That's why this will be the formula. Is this clear? Okay. Propanoic acid can also be formed from propane 1-ol and potassium dichromate. State the conditions. Yes. What are the conditions? Very good. Acidified.
Also, under alkali gas.
Very good. Heat under reflex, because if with propan 1-ol, if we do heating followed by distillation, then it's a propanol. Yes, Omar.
The question,
Sorry.
the question.
That propanoic acid is formed from propane 1-ol, that is an alcohol, and potassium dichromate. State the conditions required. So acidified and heat under reflex. Yes, good, Bunny. Okay, now complete table 3.1 to show the number of sigma bonds and pi bonds present in molecule of X. So what is X? Okay. X is CH3, CH2, Cn. So if we make the displayed formula, there are 3 hydrogens, 2 hydrogens, and a carbon with a triple bond. So how many pi bonds are there? Only 2. And how many sigma bonds are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 sigma bonds are there. Is this clear? Okay. So we are done with 3 questions. Now 2 questions are left, and we will end this paper tomorrow. Okay. So see you everyone in the next class. Take care. Goodbye. Allah Hafiz.